where, hey, God, the computer's going crazy again. This thing, fan is going crazy. Okay, why is my fan going crazy? I think it's VS Code. So we're on a different, oh no. I think we're just gonna have to accept the fan going crazy. Hello. Today we're gonna have a look at the Flipnote program again. And in particular, we're gonna do a refactoring that's long overdue, but maybe not entirely obvious. As always, it depends who you are, who's listening, where you're coming from, what you want out of this, whether this is an obvious refactoring to you or not. So if you're studying Comp 115 at the moment, this is something strange and new, but very interesting. But it's important. There is a way to keep moving forward with these arrays, but it's already getting awkward. So a quick refresh. We have the Flipnote program. Well, we're just getting started on the Flipnote program. If it will get up and running, maybe. There it is. So we got to the point where if I held down the 1, held down the 2, held down the 3, I could change the position of these points on this triangle, and then I could switch to the next frame and draw that frame as well. So I could draw different frames that were triangles, basically. So not very far, but somewhere. And already we got to the point where we were having to keep track of too much information to be able to do this easily, right? So there's my strange animation, pressing spacebar to make it quickly flick through. You can see it in the code here. I'm having to keep track of 4 x1s, 4 x2s, 4 x3s, same with the y's. That's because each of the points has an x and a y, and there's 4 of each of those. There's 3 points, and then there's 1 for each frame. So this is very quickly going to get out of hand when I've got something that's not a triangle, it's got more points in it, or I've got more than 1 triangle, or I've got more than 4 frames. It's really quickly going to get out of control. We need a better way to structure this data. So that's what I'm talking about today. The very basics of structuring data. We're doing it with objects because that's how you structure data in processing / Java. We've been doing it with arrays up until this point because that's a way of structuring data, but it's quite a restricted one. It's one where the data all has to be of the same type. It has to line up in a vector, or if you do a 2-dimensional matrix array in a kind of matrix shape. And this data in general is much more amorphous than that. So what am I going to do? Well, the first thing I'm going to do is take advantage of something that exists in processing, and that is the points. Let's go check the reference. Because an x and a y for a position is something obviously we want to use a lot of. What have they got here? They use these vectors. I've got to try and find it. P-vector. For processing vector. It's a class to describe a 2- or 3-dimensional vector in Euclidean space. I mean, that's the mathematical way to think of it. But I like to think of it just as an x and a y and potentially a z jammed together. So we don't do any z coordinates here, though that could be a fun thing to do to make a 3D version. Put an x, put a y in one spot so that you don't have to have an x and a y. That'll cut us down on a pile of these already. So I'll make that change first of all. I'll start using p-vectors instead of integers for the points. The first thing to remember or think about as soon as we move from a primitive type like int, lowercase I int, to a structured type like p-vector, and it's indicated by the fact that it starts with a capital P, that it's a structured type, is that it uses reference semantics instead of value semantics. Let's see if that pops up anywhere here so we get a chance to explain it. But the first thing I'm going to do is just going to switch these arrays from having x1, y1, x2, y2 to just being vectors. So that'll cut out half of them. So I don't need an x1, y1, I just need a 1, you know, like a frame 1 vector for, sorry, a 0.1 vector, because there's 3 points, one for each part of the triangle. So I guess it's vector one, corner 1, corner 2, and corner 3 instead of x1, x2, x3. So let's introduce those. I'll do it down here. P vector C1 equals new. Now, there's no reason we can't make arrays of p vectors in the same way we made arrays of integers. So I can make that just like that. And I'll need C2 and C3 just as I did before. And what I'm going to show you now is the big wins we get from doing this, just in naming. Okay, so we haven't made a huge jump. We've gone from 6 arrays to 3, but I think that's a jump. So in the setup here, what I've done is I set it up so that the x1 on frame 0 had some values just to get me going. So I can do that again. x1, y1, x2, y2 don't exist anymore. So instead what I need to do is I need to go to the corner 1 frame, and corner 1's frame has some values inside it. It's not just an integer now, it's a p vector. So I can look at the reference to find out how to get values out of it, and I can see them right here. If I've got myself a p vector, well, this is how I make a p vector, sorry. I can make a p vector by passing it 2 integers with this special syntax. I give new, the name of the type, and then the parameters it needs. And it always needs 2 because that's exactly what a p vector is. It's storing 2 values for me. So C1 frame is not just 10 anymore. It's the x1 and the y1, 10 and 10. 10 and 10. And C2 frame is 20 and 0. So even if I don't know exactly what a p vector is, I can see that I'm getting a bit of a win here because this is shorter. But I mean, shorter is only a win if it's actually more readable. And more readable depends on what you already know. I think this is more readable though. So the third point still was 0, 0. So that's now created the first frame with some default values. They're not very useful default values. We might change them to something more useful. See if that looks any better. So for the first frame, the first corner is a vector of 100, 100. So that's our x of 100 and y of 100. Now before we had multiple arrays for each one, so we were using all these arrays very carefully down here, and the names were helpful, right? The x1 was telling us we were in the x slot, and the y1 for the y slot. We can't do that anymore. We have to use the c1s. So I'll delete these to make the compiler complain. Yeah, is the compiler complain? Well, I will if I compile it, but I haven't got the auto compilation processing thing set on yet. So this x1 is no longer valid. This should be something else. What this used to be was, I'm currently in frame whatever, frame 0, frame 1, frame 2. I want you to draw me the triangle for that frame, please. So I need to know the x coordinate of the first corner and the y coordinate of the first corner. And that's what went in here. Well, the x coordinate of the first corner is now called c1.x. So c1 frame here is a p vector that I put in there. And if I ask for the x, and this dot notation is asking an object for something, I'll get back the 100 again. And if I ask for the y, I'll get back the 100, the other 100. And I just continue that with all the others. So you become c2.x. So there's no big wins in terms of size or really understandability here either, but it hasn't gotten worse. And because we often find that if we make something better in one part of our code, it's worse in another part. And then we have a text for 1, 2, 3. What were they? Ah, that was me drawing the text around that point on the screen. So again, I've got to say that point's no longer x1, y1. It's c1.x and c1.y and c2.x and c2.y and c3.x and oops, forgot the .x, c3.x and c3.y. I hope the fan on my computer is not coming through too much on the stream. My apologies if it is. Switched to a different computer to try and deal with the shearing issues, but now it's probably introduced a an issue with the computer not being powerful enough. It's an old Mac Mini that's being pushed to the limit. Alright, nearly done. So now when the mouse press happens, we need to update the positions. Before we were using the mouse X to update the X array, but now there's no X array, there's a corner array. So we want to update the X position on it. And there's a corner array, so we want to update the Y position on that. Same thing, if we're holding down 2, we do it to the other one. .x, .y, and corner 3. .x, .y. Let's run this to see if I've broken anything. Sure I have. Yep, restart. Cannot convert from p vector array to p vector. So somewhere I'm there we go. Each is an array of p vectors, not a p vector itself. So I messed that up when I created it. The method string float float in the type p-applet is not applicable to the arguments string p vector because I forgot the x there. Oh, I put the X in the wrong place. I've really got to get the processing version of this a bit better so I can see my errors live. Are you going to run? Yes. Ah, good. So our first one's a little bit better. And then we moved frame 2. Oh, I had a null pointer exception when I tried to move to the next frame. What happened there? Let's have a look. Yep, let's close that down. So when I tried to move to the next frame, which was pressing space, I set the integer new frame equals frame plus 1, and then I modded it by 4 to make sure it didn't go beyond 3. So it goes 0, 1, 2, 3, 0, 1, 2, 3. Where did I get this null pointer exception? Well, what's happened here, if we go back up and look, I put into one of the things to know about reference values instead of normal values, so the integer char boolean, they're normal values. When you don't initialize them, some value is made up for them. A value like 0 was made up for an integer. A value like false is made up for a boolean. But as soon as you move to reference types, things that are more complicated, there's no sensible value for processing to make up for you. So if you don't initialize it, you get null, this magical value that just breaks everything. And that's what happened here. Before, when we had an array of integers, they were initializing all to 0 and we got away with it. But when we moved to an array of vectors, they initialized to null. And that meant later on when I tried to do something with a null, it crashed. I tried to do something with null as soon as I went to the second frame. And that was because I've only initialized the first frame. I need to explicitly initialize every frame now. So int I equals 0, I is less than, well, the length of these arrays. So C1.length, I can use any of the arrays, they're all the same length, and I++. Just for those who know a bit of Java and are wondering why I'm still using a for loop instead of a for each loop, well, this is processing, and we stick to the simpler version. Maybe the for each loop is available, but it's not officially part of processing, so we use the explicit for loop. So that'll make the I go from 0 through all of the different values that are going to go in that frame, all the different values that frame can take. And that means that if I move that code into there and stop using frame in here, I use I instead, then they'll all get initialized to that. And I won't have that null pointer exception anymore. It also means that every frame is initialized to the same thing now, so if I space through the frames, they're all the same. And if I change frame 1, frame 0, the other ones are there. Good. Okay, I've managed to recreate my program and make it a little bit better. Excuse me. Okay, I like that. This is definitely a win, moving to p vectors to store the x and the y. But there's another thing I don't like. It's the C1, C2, C3. I really don't like, I mean, it works because I've got a triangle, but if my shape was any more complicated than a triangle, am I going to have C4 for rectangles? And then what am I going to do when I'm combining rectangles and triangles? I don't really love this. So I've got a couple of choices. And the most obvious choice, I think, is to move to processing shapes instead of doing the triangle explicitly myself. And back to the reference, eh? Okay. Well, that's one heck of a shape. With processing, something that is a shape, just like I wanted to put x and y into a single thing called a p-vector, if I want to put corner 1, corner 2, corner 3 into a single thing, the single thing it goes into is a shape, a p-shape, for processing shape. I can hear the fans firing up again. Let's see if killing off some Java processes helps there. I want a p-shape, and this is my example. Now they load a shape directly, which is cheating. We're going to make our own shapes. What does a p-shape look like? Okay. Well, from the looks of it, p-shapes have a pile of methods. Is visible, set visible, disable, enable, begin, end. But here's where the action is. The sequence for making a p-shape is normally to begin a shape, then add vertices, and then close the shape. Once you've done that, the shape is kind of a single variable that you can pass around and do what you want with. Let's have a look. There's an example of creating a shape using the begin shape and end shape. There we go. So to use p-shapes, I mean, we're not even really understanding the details here of what's going on. We're just using it, and that's what a lot of processing programmers will do, but I want you to understand the basis of what's going on here. Because things are getting more complicated quickly. To use a p-shape, I now have to be doing begin shape and fill and vertex, but I mean, these are things I might think about. I certainly know how fill works, but this isn't just fill, this is s.fill. What on earth is that? Well, if I know processing, I know that I can just do shape.fill, but what does it mean to do shape.fill? I want to try and give you a bit of an understanding of what's happening underneath. An intuition of the way objects are working in processing from the point of view of someone who's just been thinking about arrays as structured data, strings as structured data, who's just starting to get into structured data. So we'll go back to think about p-vectors to talk about it. Do I want to make a single p-vector to make life easier? Yeah, well, I'll do that. I'll make a single p-vector, which is just the center of the screen, because it's a bit easier to work with just that. So one p-vector represents the center of the screen. Normally the center of the screen would be an x and a y, but the p-vector allows me to combine the x and y into one structure. So I'll build that here in my setup. I don't need the redeclaration. Just like every variable, I have the declaration for it, which is up there on line 5. I have the initialization for it. Width div2 and height div2. Okay, so what would this look like without a p-vector? This would look like int center x and int center y, and down here I'd have center x equals width div2 and center y equals height div2. So these lines here, like 6 and 7, are the exact same, or almost, not really the exact same, are the equivalent of line 5, and 15 and 16 are the equivalent of line 14. But they're not the exact same. p-vector brings us a lot more. But I did want to point out declaration of an integer, initialization of an integer, just like normal, declaration of a p-vector, initialization of a p-vector. So you can see there's something different. And the thing that's different is that when I initialize just an array, value just gets chucked in. I mean, width just 2 is a value. When I initialize a p-vector, I have this. This here is a double step. It's a step that's called memory allocation and initialization. Anytime you see a new keyword, you know you're doing memory allocation. Memory allocation means this thing I'm building is bigger than one slot in memory. So please go away and find enough slots for me and then come back. That's what it does. When you do integer center x, it's obvious you need one slot because an integer goes in one slot. So the slot is available and you just chuck the integer straight into it. When you're dealing with bigger, more structured data, p-vector don't necessarily know exactly how large it is yet. And certainly it's bigger than one slot. That's the real killer. So what the computer does is it sets aside just one slot at this point and calls that slot x. And then it has a second step called memory allocation, where it goes off and finds enough space for the whole p-vector somewhere else in memory, and it makes the center variable, that one single slot for center, point to the extra memory that it created. So center doesn't store the p-vector itself. It only stores a reference to the p-vector. I'll use the terms reference and pointer interchangeably here because they're fine to be used interchangeably, but some people have different definitions for each. It just means the thing in center is not the value itself. It's not the whole p-vector. It's just something telling me to go looking over there. That's where I'll find the p-vector. And then I follow that, the path that it gave me, the reference it gave me, the pointer it gave me, whatever you want to call it. And over there I find the p-vector. And it's a big thing, which is why it had to be over there. You can think of it like unwrapping your Christmas presents. You unwrap the small presents and you've just got a piece of paper, you chuck it straight in the bin. You're like, that fits in a bin slot. You unwrap your new bike and you get this giant cardboard box where you just chuck that outside to where you got more space, and you remember to yourself, cardboard box is out there, go deal with it later. That's what this is doing. It's saying, look, make this giant thing off somewhere else. It's not that giant, it's just an X and a Y jammed together, but it's too big for one slot. And just remember where it is and put that in center. And that's why that center variable gets the special value null. So in between this bit here, in between line 5 and line 14, what is in center? Null. Well, in between line 6 and line 15, what's in center X? 0. That's a big difference here. Okay, once we do that, once we make this p vector, make it larger, possibly larger than a single slot, we can put anything we want in there. We can make a p vector a big amorphous blob of all kinds of wonderful, useful things, and that's exactly what we do. We don't just put an x and a y in there, we put functions in there too. And the functions that are hidden in there are all available using a special syntax, the dot notation. If we go back to the vector, I'll do it here, reference, excuse me, p vector. It'll tell us not only that there's an x and a y in there, and a z, because we can do it in 3 dimensions. It calls them fields. We can get them back out, which we did down here. I'll show you more explicitly how to do that. Let's just draw that single center point to make things a bit simpler. It gets drawn as a point, right? So when you put point in processing, you have to tell it the x and the y of the point. Well, I don't know the x and the y of the center. I know it's a p vector. The p vector is a big amorphous blob somewhere in my memory that's pointed to by the center variable. But that amorphous blob can be asked questions, and it will give me back answers. One of the questions I can ask is, what's your x? It shows me here. I can ask it x, y, z. I can ask it set, random, from angle, copy, whatever. All of these other things. All these are jammed in that. We can think of all of these as jammed in that blob of memory. They're not all really in there, but we can think of them all as jammed in that blob of memory. So certainly I can get the x, right? Center dot x, and I can get the y. So I'll be able to draw that point. Can I run this? Or am I in a state of half brokenness? No, I can run it. There's my point in the center. But I can actually do other things to this vector. Let's have a look at the ones it says. I can rotate it, get the limit of it, cross it, dot it. What on earth do any of these things mean? Well, I have to look into the documentation to see what they mean. But the vector object is what we call it, that amorphous blob in memory. We call it the p vector object, is also the repository for all the different things we might want to do with a p vector. And certainly one thing we want to do with a p vector is set its variables. We can reset them from where they were before. That's very useful. And you do that with the dot notation. There it is, vector dot set. You should think of all of these guys here, these fields, as just variables, just like normal variables, that have been squirreled away in the amorphous blob. So there's an integer x. Is it an int or a float? We don't really know. Doesn't tell us here. I'll assume it's a float. There's a float x somewhere in that blob of memory. There's a float y somewhere in that blob of memory. There's a float z somewhere in there. The methods we should think of as functions that are off in that amorphous blob as well. So there's a set function in there somewhere. There's a, right? The only magic we have to know is that instead of just being able to access those variables or functions by putting them in like we used to, we have to say, please go and find that amorphous blob and then look for the function in there. And we do that with the notation. So if I want to move this guy a little bit, I want to do the set thing, right? It had a set function. I'll move it to, I don't know, center at the top. And we'll just make it 10 in the y direction. But I can't just call set directly, because it's not a global set that I'm talking about. It's the special set that the p vector has. So I say, well, please go find that p vector and use its set function. How do I find a p vector? I go and ask that center block. The center block is the one that's keeping track of where that p vector is off in memory. So I just say, look, center block, what's your arrow? What's your pointer? What's your reference? What's your path? Follow that path, and at the other end you'll find a set function. Please run it. So now he's moved up the top, just like I might have hoped. So there's a lot more to go on this, but we can't do Flipnote without a heavy use of objects. So we've done our first intro to objects here, and we'll build on that a little bit more as we go on. Otherwise, that's what I wanted to say today. So that's all for now.